Okay, this is from section. This is from section 2.6, question number 15 in the My Math Lab, I believe. And here we're asked to evaluate a given limit. So it's worth asking the question, why does this show up in section 2.6? Why not an earlier section? And we're going to talk a little bit about continuity here. So if I give this function a name, let's call it f of x. Before we get going too far, let's ask the question, where is f continuous? Well, f is continuous. We had a theorem that said that for a function that's built up of trig functions and polynomial functions and the basic operations, this type of function will be continuous everywhere it's defined. So asking the question, where is it continuous, is the same thing as asking, where is it defined? And that should be a question that you're maybe a little more familiar with. Well, I'm doing some sine, some squaring, some multiplication, some addition. All those operations are just fine. The only problematic operation in this problem is division. So we need to make sure that you don't divide by 0. I guess don't above that. So when would you be dividing by 0? Well, you would be dividing by 0 if the expression sine of x plus 1, if that evaluated to be 0. That would happen when the sine of x evaluated to be negative 1. When does that happen? Well, let's look at our sine curve. Our sine curve looks something like this. And when are the y values of the sine curve equal to negative 1? Well, that would happen right here. It would happen right here. And if it continued, it would happen again here. It happens at every other odd multiple of pi. So that would happen when x were ... let's say negative pi over 2. The output would be negative 1. Not at pi over 2, the output would be 1 if it were pi over 2. But at 3 pi over 2, it would be negative 1. Not at 5 pi over 2, that would be right here. But again at 7 pi over 2, etc. So it's every other odd multiple of pi over 2. That's where f is defined when you exclude those values. So f is continuous, x not equal to ... negative pi over 2, 3 pi over 2, 7 pi over 2, ... Well, unfortunately, if you go back to our question, what are we asking to find the limit of? We're asking to find the limit of 3 pi over 2, which is one of our excluded values. So that means we have to do a little more work. Okay. So if we return to our limit, the limit as x approaches 3 pi over 2 of the sine squared of x plus 3 all over the sine of x plus 1. Excuse me. What could we do with this problem? Well, we could go ahead and see if we can factor out the expression or cancel out the expression in the denominator that's preventing us from using direct substitution. So let's see what we can do. Well, it turns out the numerator factors to be the sine of x plus 3 times the sine of x plus 1 all over the sine of x plus 1. And then we can see that, yes, indeed, we can cancel out these two factors. So I feel like, as I recall, the person that asked this question asked, how do we do that factoring? Maybe you haven't done factoring with trig functions before. So if we return to the factoring step, the sine squared of x plus 4x plus 3, and let's just look at that. Well, let's use what's called a u substitution. That might help make the problem a little easier on the eyes. If I let u, and let's see, notice I copied this wrong. So it would be sine x plus 3. It's copied correctly now? Yeah, I think so. So if we let u equal the sine of x, that means we could rewrite the problem as u squared plus 4u plus 3. Put another way, we could look at this trig expression right here as a quadratic expression. We'd say that it has a quadratic form. After we do the u substitution, the fact that it's a quadratic form is much more clear. So now we can just factor this. Now this should seem a little bit more familiar. This factors as u plus 3 plus u plus 1, and then you could go ahead and back substitute what u was holding the place of. We end up with this. So that's how this expression factors. That's nice, because now, once we write it in this reduced form, we have a new function here. We could say this is g of x equal to the sine of x plus 3, and g of x is continuous where? It's continuous from minus infinity to infinity. It's continuous at every value in its domain. Or at every value on the real number line, actually, more precisely. What does that mean? Well, remember what it means if I say g is continuous at x equals a. That means that g of a is equal to the limit as x approaches a of g of x. Well, this says that if I ask you to evaluate the limit of a function that's continuous, and I'm asking you to evaluate the limit at a place where it's continuous, then evaluating the limit is the same thing as evaluating the function. Put another way, we're able to use the property of direct substitution on this. So we couldn't use the direct substitution property before because the limiting value was a place where f of x, the first function, was discontinuous. But through some rearranging, we've broken it down to a simpler function that is continuous at our limiting value, and everywhere else for that matter in this case. So now we can go ahead and simply evaluate the corresponding function in lieu of taking the limit. Well, the sine of 3 pi over 2 is negative 1, and we end up with 2, and that's our solution. Hope this was helpful. Here